If I fill out all of this information, I should be able to come up with a pretty good graph of what this looks like. I'll start with the easiest thing, the y-intercept. When I plug in 0 for both x's, I get negative 3 halves, negative 3 over negative 2, which is 1.5. So I know the graph goes through there. Similarly, if I make sure that y is equal to 0, so 0 equals x minus 3 over x minus 2, all I really care about is when the numerator is 0, so I know I have an x-intercept at 3. Those were pretty easy to come up with. Now I go to the difficult ones. My limits at infinity are still the easiest, because when I plug in a very large number, we're looking at y equals x over x, which equals 1. And that's the same thing whether I plug in infinity or negative infinity. So really that means I have a horizontal asymptote at y equals 1. The last piece I need to do is figure out what is the behavior on either side of what appears to be an asymptote, because that's when I'm dividing by 0. So to figure that out, I will look at things, I'll look at 2 in the numerator. So I'm really looking at 2 minus 3, or negative 1, over x minus 2. Well, if I think about what negative 1 over x would look like, it would not be this, it would be the reflection of that, because of the negative sign. So it's actually the red curve, and this is just shifting us over 2 to the right. So what that means is when I look at the red curve, as I approach 2, because we've shifted right, on the negative side I'm shooting up to infinity. So this would be infinity. As I approach 2 from the positive side, I'm shooting down to negative infinity. So now I can draw my asymptote in. My behavior on the right side of 2 is coming up from infinity, going through that 0 and approaching my horizontal asymptote. And on the left side of 2, I'm coming down from positive infinity, going through that y-intercept and approaching the asymptote on the other side. Now use these for some of the problems to follow. Use these concepts.